Everyone, welcome back. This is Engineer Sam Wasabi, and this is the continuation of our mathematics revision. All right, so in this question, we're having logs. Yes. All right, so before we begin, do not forget to like and subscribe. All right, so they're saying solve the equation of the logs given. So, okay, so basically, one thing you need to know is this. Logs and indices, it's like they're in a relationship. These guys have common entities. So remember, if you have a to the b, maybe this is equal to an answer or a value, you know this is the base, and this guy is the power, and obviously this is the answer. A log is always in the form log base answer is equal to what? Power. What I'm trying to say is that if I have log 2, 5, if I want to solve this, I can just say, okay, what is this guy equal to? I don't know, so I say x. And I'll try to convert this to an index form. And I'll know that, okay, a should be the base. So the base is 2, which is here. And the power is x. Okay, so that's that. And what's the answer is 5. So logs come in when you have an index that you cannot evaluate. Because for me to solve this, I have to make sure that here I have a 2. And I have to ask myself to say, how many times can 2 be raised to get the actual value that was there, which was 5. Now, it's difficult to think about that. But the best way to do it is to apply logs. But now, in this question, we don't really have to dive so much into the log properties. I just want you to know that if you have any log in a base that is not in natural form, like for instance, whenever you have a log just given like that, this simply means that this is log 10, which is a natural log. Like it's natural. So, if you have any log other than in base 10, say a, where a is not 10, base 10. Let's say you have log a, then b. To convert this to base 10, you have log b over log a. And this has now been converted to base 10. So these are the approaches we're using. So now, the first thing to do whenever you're solving a log equation is to make sure that you're only having logs on one side of the equation. Like you're having a log on just one side of the equation. So I'm going to try and do that. I'll try and make the logs. Oh wait, in this question, do you really think I have to do that? I don't have to do that because I'm having logs on both sides of the equation. So it's point to say that it's not really necessary to start dividing or doing any other thing. So with this at hand, it means that we're having log base 2, then x squared plus 8, and this is equal to log base 2 x plus log 2 6. Okay, one thing you should also know about logs is that whenever you have, let's say, logs of the same base a, then b plus log same base a, then c, this is equal to log of b times c. And then if you have log same base b minus log same base c is equal to log of b divided by c. Please remember this. So I have to make sure that I only have one log on one side and one log on the other side. So this side I only have like one log, which is log base 2 of x squared plus 8. And this is equal to this side I'm having two logs. So I have to make like one log that simplifies the two. So between the two, it's the first one, which is star, that represents what I want to do. So to be log 2, and again I'll say x times 6. Then this will be log of base 2, which is x squared plus 8 is equal to log base 2 of 6x. Once we reach this point, I want us now to apply the rule that means, or that states that we have to convert. Now, what you do is first is that whenever you have a log equation, make sure you have log this side and log the other side, like one log on left, one log on right. Then once you do that, make sure that the two logs are in natural form, they're natural logs, are in base 10. So I have to convert in this form as star. So if I have log base that, this will just be log of x squared plus 8 over log 2 and is equal to, again, log of 6x over log 2. As you can see at this point, I am having something that is or can be simplified. So now once I convert to base 10, what I can do is just to multiply the bottom, to eliminate the bottom. Like I said, I don't like bottoms. So what we can do is that is to eliminate the bottoms there. So we can say times log 2. When I multiply times log 2, this guy will cancel with that guy. Even that guy will cancel with this guy. This, you know. So I end up having log of x squared plus 8 and is equal to log of what? 6x. Now I want you to understand something. When you reach this point, there are many approaches you can use, but basically the approach I love to use is anti-logging. You know, when you anti-log, then it means you change the log to something else. So at this point, anti-log. What do? You introduce e to both sides of the equation in the sense that you are raising the log values. So anti-logging simply means I'll introduce e, then raise everything to the anti-log. So this will be log of x squared plus 8 and is equal to anti-log the other side, e, yes, log 6x. Remember, it's like you're having the same base. Then like the powers are there, isn't it? But now, the funny thing with anti-logging is that e cancels out with the log value, and this also cancels out with that log value. And all you end up having are the powers that you have to drop. So you have like x squared plus 8 is equal to 6x. At this point, you know, x squared, this can jump and be like minus 6x plus 8 is equal to 0. Then you can look for the sum and product. So the sum is minus 6, the product is 8. What are those two numbers? So those two numbers are negative 2, is it? And negative what? 4. So this would be x minus 2 and x minus what? 4. Like that. This is equal to 0. So basically, I'm trying to say that x is equal to 2 as my first value of x, and x is equal to 4 as my second value of what? X. If you did plug in this log question here, you realize that the answers that were found are correct. All right, so this is how you go about solving log questions. Yeah, so remember the steps, remember what I've actually done, and apply the similar thing. Apply the similar thing. Yes. Okay, so maybe okay, let me just give you just like one. Let's just do like one simple question on logs, just like one. Okay, let's say just some playoff question. Let's say 4 plus 3 log let's say 2x is equal to 16. So as you can see, for this log that we have in this question, do we really have to convert it? No, it's already in its natural form. So I can just solve this. Remember, make the log as the only thing on one side of the equation. So you have 3 log of 2x, and this is equal to 16. Why? Because the 4 will jump and go the other side, and it turns into a minus 4. So you have like 3 log of 2x is equal to 12. Then I can divide both ends by 3, and I have log of 2x being equal to 3 into 12 is basically 4. Now remember what I said. Should we use that approach? But it will work as well. Remember, A is the base, B is the power, you get the answer, isn't it? So if I have log base answer and is equal to the power, and I can convert this. So my base will be, remember, base 10. So 10 to the power, which is the answer, 4 is equal to 2x. So I'm having 2x being equal to 10 to the power 4. 2x being equal to 10 to the power 4. So we know 10 to the power 4 is like you saying 2x is equal to 10 times 10 times 10 times 10, then divide by 2, I have my x being equal to, okay, 2 there, 1, 2 there is 5. So 10 times 10 times 10 is 1,000 plus 5 is like 5,000. And that's the value of what? X. All right, so basically, in most cases, you'd find that questions like these might arise. Yeah. But what I'm trying to say is that it might look tricky at first glance. Like in most cases, anything that's new is tricky, like really tricky. But if you keep on practicing, you really get better than your current situation, your current state. Provided that we try by all means to put in our level best, we will get there. All right, so if at all, we did plug in for this value, it should end up working. It should end up giving the value that we're interested in, which is basically 16. All right. So remember, if you have queries, you can always reach out to me on WhatsApp on the line 077-149-5252. And remember, slow progress is better than no progress. And let's strategize before becoming a statistic. Let's try and push for that. A plus.